Okay, guys, welcome back to my channel. So now I just want to quickly show you how to configure RIP, which is Routing Information Protocol, right? So we want to share the routing information from one local area network to another local area network. Let's say, for example, we have two routers which are representing maybe two different networks, and then you want to share that information within the routers, right? So the thing is, the router or the router has information about the network that he is directly connected to. So if the router is not directly connected to that network, so it means, in other words, like it doesn't know that network, right? So it won't be able to forward any packets to that network if it doesn't know, or if there is no path that has been defined. So I just want to quickly show you how to uh, configure RIP, and then let's say we have one PC there, and then we have the same thing this side, and then let me add a switch. There is a switch. I want a simple switch, which is the 2960. I might be using these two switches, right? And then let me quickly use auto there to plug all these devices. And then there, to that, there, and then plug it to that. I want to quickly configure this, and then, so there. So what I'm saying is these two routers, right? Each router has knowledge of the network that he is directly connected to. So this router, each interface on a router, it's a network, represent a network, right? So let me quickly assign. Let's say this one is a what if it's a 192.168.10.0 slash, let's say, 24, right? 192.168. Let's say it's a 20.0, and then slash subnet of slash 24. 192.168.30.0 slash 24, right? So I have all these three networks, right? So these three networks, it means that this router here, we have this router 0, which is router 0. The router 0 is directly connected to how many networks? To these two networks, right? So that means he has knowledge of these two networks because he's directly connected to. But this router here doesn't know about this network, so he will rely on this router to tell him about this network. So we call it the routing, right? The routing information protocol. We're going to use RIP to share that information between these two routers, right? We can use manually, whereby you as an administrator, you tell the router how to reach to the other side. So let me quickly, okay, so we're focusing on RIP. What happened? Okay, so we have those two networks now. We have those, okay, fine there. And then you have three networks now. So now I just want to quickly configure this router, assign it an IP address. So I'm going to be assigning these two networks. So I want to display the interface, the port numbers, right? So I just need to go to view, and then say, is it options, and then preferences, and then say always show port labels, right? I want to see the port labels, port numbers. You can see this one is a gig 0/0. I want to assign an IP address to that. Okay, so say no, and then enable, and then configure terminal, and then I go to interface, which is G0/0, and then I say IP address, which is it's under. So I'm assigning so you have to go to inside the interface to assign an IP address. So I'm inside the interface gig G0/0, which is this one at the top. You can type it out as gig 0/0 or G0/0. So I want to assign this IP address and interface, right? Sorry, this interface and IP address. So I want to assign this one. So 192.168.10.1. So I have like 254 available assignable IP addresses. So this one gonna be my one, and then this part gonna be my two, right? So I want to start with the one, 192.16. Sorry. 168.10.1, and then subnet mask /24 255.255.255.0, and then say no shut, which is means no shutdown. I'm switching on the interface. You'll see it will say change state, interface recovery state to up. All right, no shut. And then now I have to go to inside this interface, which is a gig 0/1, and then assign it an IP address. But I want a shortcut, right? I want a G01. Then you can see now I'm inside the interface, but you can type it all like interface. But if you're in the field, you rely on the shortcut of the commands, right? So, okay, sorry, I don't need to. Let me say IP address 192.168. Dot. Now I'm on a 30, right? 30. Let me make it a 30.1, 30.1, and then subnet mask 255.255.255.0, and then say no shut. That interface has to change color to green, right? Meaning that is up. So if you want to switch on an interface, the command that you type in is no shut, which is no shutdown in full. No shut. So I'm going to be on this video, I'm going to be using the shortcut commands, right? There's another video where I went through the full commands. So it's my first video. You can go through that first video and then try to learn the commands, the proper commands, the full commands, right? So this one is also a proper command, good command. It's just that it's for when you're in a production environment, right? Like you are lazy to type the entire command. You want to quickly sort out your network and then be back online and things like that. So I don't have time to type the entire command. I just use the shortcuts. So you'll see that in a production environment, you're going to be relying mostly on the shortcuts. Okay, now let me check. Let me say show IP interface brief. I just want to see if I've applied the IP addresses to that interface. So you can see here it says gigabit Ethernet 0/0. It has an IP address now, right? You can see there is the IP address. I made a mistake there. Instead of a 192.168.10.1. So this is what I always do. Once after I've assigned IP address to different interface, I come here and then I check if I have applied the correct IP addresses. As you can see now, I wanted this to be a 10, not to be 101. Okay, now I don't have time to rechange that. So let me just change this part here and then make it 101, right? So that means this device here is now a 101, and then this one will also be an under 101. Okay, but we can um, remove that IP addresses by typing no shut. No, you can type in no and then IP to remove that. It's a command to negate to remove the IP address. So you see, it says also down here because the other end is still off. So I have to come this side and then also configure this router so that also that router can have an IP address. That interface can have an IP address and then switch them on. And then say enable, say interface. Okay, I'm in the wrong platform. Command. Sorry, config, man. What happened to my brains? Config terminal and then interface gig 0/0. So now I'm inside router 0, which is this router, right? Router 0. And then interface, sorry, IP address, which is 192.168.168.101, since we have changed that, and then .2 255.255.255.0, and then now I need to assign IP address to this interface now, gig 0/1, and then interface gig 0/1, and then IP address, which is 192.168.20. Let me make it a 1, and then subnet mask 255.255.255.0, and I say no shut now. You see now it says line protocol on interface gateways change state to up. So now if I say show, so let me say do show IP interface brief, you can see now says that interface is up 20.1, but gig 0 is not assigned an IP address. Why is that? I thought I did. Okay, let me assign a 0.0 and say IP. How did I miss that? 192.168.101 dot, we said it's a 2, right? 2, and then 255.255.255.0, then say no short, and then end. So you want to check if you have applied the correct interface, you've assigned correct interface to the correct IP addresses, right? To the correct interfaces. We have assigned correct IP addresses to the correct interfaces. Let me check that. So the command is show interface brief. Now show IP interface brief. So you can see state is up, manual up, and then protocol up. So everything looking good now. And then also you can see here manually a screen there and then a screen there, right? And then check the IP addresses. Is it correct IP address? So gig 0/0 is on a network of 101. There's 101, and then gig 01 must be on a 20.0. There is 20, right? The other thing that I want to show you is the routing table. Show IP route for the routing table. So what happens is that these routers, once they learn about any network, they put that network on their routing table, right? So that they will know how to forward a packet once they receive the packet, where to forward it to, right? So if they don't have that network within their routing table, uh, the system will tell you that, okay, destination not reachable. It doesn't know how to send that or where to send it, right? So as you can see here, it knows about only two networks that is directly connected to, which is this network and then that network. So here it says connected, right? As you can see, connected to 20, and then it says it's directly connected via which interface. It shows you, it says I'm connected to this via gigabit Ethernet 0/1, which is this one. And then link, there you can see, and then the IP address 20.1/32 is directly connected to that interface, right? And then we have this 101, there's 101.2, right, which is directly connected to gigabit Ethernet 0/0. So you have all that information. So it says it only knows about, it shows us that it only knows about how many networks. If you check all the connected ones, it's a 101.0, and then the second one says 20.0. So it only knows about two networks. It doesn't know how to communicate with devices that are on this part. So let me assign these devices an IP address, desktop, IP config. So this one is under a 30, so it must be a 30.2 because the router already took one. 192.168.10 dot, no, sorry, it's a 30.2, and then the router is 192.168.30.254, and then the DNS server, we don't have a DNS server, so I'm gonna leave that one out. So there we are. And then let me see, let me also assign this one an IP address, desktop, and then look for IP configuration platform, and then static 192.168.20.2, and then 192.168.20. It was 1, right? So 1 is the IP address of the router on this interface though, right? So as you can see, the router has two networks, right, which is this gig 0/0 at the top, and then so each interface within the router is it represent a different network there. Okay, so 20.1 is the IP address of the router. So default gateway represent the router. The router is the one that takes a packet from this network, right? 20, and then is the one that directs it to that router, and then that router takes it and then sends it to the correct PC on this side. But first, they need to know there must be a path, right? It says, okay, this one can only communicate using maybe this network and that network to this one, but it doesn't know this network. So it needs to have this network within its routing table. So now let me test my devices. I want to test connectivity between PC0 to, PC0 to the router, right? Our router IP address, we know that is this is a 20.0, so it must be a 20.1. So there is a 20.1. Let me close this. So I want to ping the router using this device now. Let me close that there, and then go to command prompt, and then I say ping. Ping is a command that you use to test connectivity between two devices. 192.168.10. Nope, it's a 20 there. 20.1. So I'm pinging my router using PC0. You can see it says reply from 192.168.20.1. So that means there is connectivity between the two devices, right? So they can communicate. All right, fine. And then now I just need to check if this router is able to communicate with the next router there. So also ping, I type in there, ping 192.168.101.1. So I'm on this router, which is router 0, as you can see, router 0. So I'm on router 0. I want to ping this router, this interface on this router, and then find out if they can communicate. So you're supposed to see there it is. We lost one packet, but we have all those other 4. So that's the response coming from that router. So there is connectivity between the two. And then now I'm on this router. I want to ping this PC. Let me see if I can be able to ping. Let's say ping 192.168. This router, this PC must be at 30.2. 30.2. If you're not sure, let's check. Let me quickly show you the IP address. See 30.2. So let me just quickly go back to the router. I mean, there I am. And then you see connectivity between the two. See, there's connected, right? So now, since there is communication along this path, so I want to be on this PC0, and then ping PC1. As you know that PC1 is the IP address of PC1. We said it's a 30.2. So I just want to be on this one, and then ping 30.2. So let me say ping 192.168.30.2. Says destination was unreachable, right? It doesn't know. And then check where the reply is coming from. So we're pinging 192.168.30.2, right? That's what we're pinging. But look at the reply. Where's the reply coming from? The reply is coming from 20.1. Is the one responding saying, okay, destination was unreachable. I couldn't reach that destination. So meaning that the information is coming from the router is the one that is responding, because the 20.1 is the router. The router is responding because a router is the one that has the responsibility of taking packets from this network to other networks. But he's saying, okay, you are trying, the router is saying to this PC, which is a 30.2, this PC here says you're trying to ping 30.2, but I couldn't reach 30.2. It says destination was unreachable. Even though that we verified that, okay, there's the communication in this path, but now it might have reached there, but it doesn't know how to get back to this part. So it says destination, I couldn't reach the destination. I don't know where that network is. Right. So I want to show you on this part. Let's say show IP route. That's the information. As you can see, this one also has two networks within his routing table. Say you check the C. The C shows you which networks is it connected to. So 30.0. So he says, okay, I know 30.0, which is this one. And then he also knows C connected 101. Says, I know 101.0, but there's one network which is missing, which is S.20. So that's why now we are on this LAN. This LAN can communicate with their second LAN because these routers, they haven't learned all of the networks. So now what happens is the routing information, it's just that these two router by default, we said this router by default, we said it will know all the networks that he's directly connected to. So this guy here, this router is directly connected to two networks, so he only knows two. So who's going to tell him about this? So we want to do what we call, we want to use the routing protocol called RIP, right? RIP is the one that is going to allow these two devices to share information. So this router here has to share this network with that router, so that this router now on his routing table, he must have at least 3 networks, so that these two devices will be able to communicate, right? So we want to configure what we call the dynamic routing protocol, which is RIP, one dynamic routing protocol. Dynamic protocol Dynamic routing protocol is whereby we have a protocol that we're using to allow the routers to share routing information. So we want to use REP, which is one of the old routing information, and then it is a limit of like 15 routers. So it is mainly used like on small networks. So that's why I want to use the REP right now. So let me quickly show you the REP. Okay, so you've seen now, I've shown you, okay, this device can communicate with this other device, even though the path is short as, okay, from here to here, from here to there is communication. The line is fine, and then from there to there, the line is working fine, and then from here to here, the line is working fine. The problem is just that this router now doesn't have that information. That router doesn't have that information, so that's why these two devices are not able to communicate. So we just want to fix that using the router, the RIP. So you have one LAN trying to communicate with another LAN. So what you need now within this is just that we need a dynamic routing protocol that will allow the routers to share that information. Okay. So now sorry, why am I opening that by the way? Okay, 21 minutes. I thought this was gonna be maximum 20 minutes. Okay, let me make sure that is 25 minutes max. Okay, so now I want to configure RIP on this platform. Let's say config t, and then the command for configuring RIP is router RIP, right? There it is, and then you type in the version that you wanna use, version 2. So these two routers must be using the same version in order for them to share the information, share the routing information. So what basically doing now is allowing these two routers to share the networks that they know, right? It's like two people that are coming from two different areas, and then they start sharing their map, saying, okay, here's the map of my area, and then the other person shares the map of their area. So in the end, those two people end up knowing those two areas, right? Knowing how to move around within that area. So that's what basically is happening here. This guy says, okay, I know this network, and then I know that network. So he shares that network with that router. And then this router says, okay, I know this network and that network. So this router here will share two networks to this router. But this router will say, okay, sorry, I already know this network, but you have shown me some new interesting information, which is that router. So I will add this router to my routing table since it's a new information. And then also this one, once he shares this one and then that one, this router will say, okay, I know this network already, but we are sharing something new. Then he will keep that information within the routing table so that next time when this device wants to communicate with that device, this router will know to say, okay, I want to send that there. And then this guy says, okay, you want to communicate with the network down here, and then sends the packet there. So that's how it works. So now we have typed in router RIP and then the version 2, and then the other command is the network. You have to specify the network 192.168.10. Okay, no, not 10, let's say 30.0. So we want to advertise this network now. So this is he's connected to two networks, so he's going to advertise only two networks that is directly connected to, and then no subnet mask. Network 192.168.101.0, right? And then no auto summary. Let me see. Oh, auto summary. Okay, I want to say no auto summary. If I'm not, no. Okay, there we are. Version, I've specified the version. Okay, so we've advertised two networks, right? Let me also try to advertise another network. Okay, let me see now. So we've advertised those two networks. Let me say copy. Let me say right. Just want to save that information. So okay, that information is saved. Let me say show IP. So now I just want to check if these two routers were able to share that information. As you can see now, that it still is like the two networks, still is that 30, and then still is the 101. And then let me see if this one has received that information. Let me say show IP route. So you can see he still has like the two networks because he hasn't managed to share that information or receive the information coming from this router one because RIP is not yet configured on this one. So RIP has to be configured on all these two routers so that they can be able to share that information. So let me say config T so that they can be able to share information. Router RIP, right? And then we say the version must be the same. We have version 1, but these ones are using version 2, right? So now we say network 192.168.101.0, no subnet mask. Network, he knows two networks, so he's going to advertise two networks. 192.168.20.1. Sorry, the entire network, 20.0. So you see, he only knows two networks, which is the 101. So he's advertising the 101 there, and then also knows the 20. He's advertising the 20. So there's no way this network will, this router will advertise this network because he doesn't know this network. He only advertises what he knows. So you're only telling your friend the story that you know, right? So only those two are going to be advertised. So and then say no auto summary, and then I want to save that to W just to save that. Now you will see something. Let's see if there is, since a RIP is configured on both routers, so these routers now must be able to share that information. So if I check now on this router 0, the routing table, it must have now three networks. It must have learned something new because RIP is configured on both sides, and then all of these two routers are using the same RIP, which is version 2. Right, show IP route just to display the routing table. As you can see, there is a new network now, or there's a new letter also added, which is R. Stands for, it says 192.168.30.0. So where is that 30? There is the 30, right? And then I'm on router 0. At the beginning, this router didn't have that knowledge of that router, of that network, right? But now he has it. He knows that there's a 30. And then how did you learn that 30? He says, I learned it via 192.168.101.1. 101.1 is this interface, and then there it is. And then which interface did you receive that information from? It says I received that information from gigabit Ethernet 0/0. There it is, coming from this side, right? And then this R stands for RIP, meaning that I've learned this information using the RIP. There is RIP, right? As you can see at the top. So there are different types of operating routing protocols, right? Dynamic routing protocols. We have EIGRP, which is for Cisco devices only, and then OSPF is for all of the vendors can use. The OSPF can use, IS can use. What is the other ones? So the BGP, all of these routing protocols. So you can see now there is a new network 30.0. Let me check if this one have length 20.0. So let's say show IP route. So there is an R there which is representing a 20.0. So now we have three networks. We have a 30, we have a 101, and then a 20. Right? How did you learn that? Via 192.168.101.2. Learned it using that interface, and then the gigabit Ethernet there. So now let's go back now to this device and try to use PC0 to ping PC1. So this was a 30.0. As you can see now, the previous reply that we received from 192.168.20.1, it was that destination host unreachable. Let me see if now we're going to receive any response from the device. It says request timed out. So the first request is timed out. Looks like the second one is going to be timed out. So now it's reaching that side, but it's timing out. That means there's something else that we need to fix. So we need to troubleshoot here and then try to find out what is it that causing these two devices not to be able to communicate, right? So it says request time out, but the message is different now. First, it wasn't able to reach that other side, but now the request is timed out, meaning that it doesn't know how to get back. There's one problem somewhere, somehow, that is stopping these two devices not to be able to communicate. Okay, let me see. Router 192.168.30.0, and then where is the other one? There it is, the R30. Let's see this side. 192.168.20. Okay, let's now try to break it down now. I wanna be on this PC. I wanna see where the problem is. So I wanna ping 101.1, which is this interface, and then find out if this will be able to ping that interface there. Let's say ping again. I just wanna find out where the problem is. Okay, 101.1. So you see it reaches 101. So it reaches up to here, but it's not reaching down here. So you can see 101 is responding. Okay, let me try 30.1, which is this interface right there, and see if that will work. 30.1. See, 30.1 is responding. So why now 30.2 is not responding? Let's see again, try again. Says request timeout. So now you can tell now that the problem is somewhere here. The packet reaches here, but it times out when it's trying to go back or somewhere there. So there is the problem somewhere here. So let's check now. Let's check on this device. You see, there is the problem. Default gateway. So we typed in the default gateway to be a 254 instead of the default gateway for this device is a 1. So now it doesn't know how to take back that packet back to this side because it keeps on timing out because here there is no default gateway that is 254. So now that's why I'm changing it to a dot 1. So now it's supposed to work. So that's how you troubleshoot your network, right? Let me try to ping that device again. Now we're supposed to get a response because we have fixed that, right? So you can see now it's working. Reply from 192.168.30.2. Now it knows how to reply. So here the problem, the issue was that the default gateway, it was a 30.254, and then there is no router that is a 254. The only router that is here is 30.1. So if you get any of these IP addresses wrong, then it affects your entire network. So now at least finally we have managed to fix that. So at least we have learned also the troubleshooting steps, how to troubleshoot any networks that are giving you any problem. So that's it for now. Thank you guys. That was RIP, the routing protocol.